Hello everyone. So today let us start to study about algebraic expressions. Up to the time we have already learned about the mathematics with the use of numbers. Whenever the word mathematics we are talking about, everyone will talk about numbers. Numbers with some kind of operations. We have different mathematical operations. It may be the addition, subtraction, multiplication, or division. These are the four mathematical operations which we are having. So what we have to do in algebraic expressions is actually saying about the numbers or the mathematics without the numbers. Algebraic expression is telling us about the mathematics without the numbers. Can we imagine something like that? Okay, we know that whenever we are talking about these four operations, we are always talking that, for example, addition, like 5 plus 4 equals to 9. If I am talking about subtraction, I can say that 2 minus 1 will give me, or instead of that I will take a bigger number, that is 8 minus 1, it will give me 7. If I will talk about multiplication, I can say that 6 into 5 equals to 30. Or if the same I am talking about division, I can say that 10 divided by 2 will give me 5. So we know that we have these four mathematical operations, and this 9 will be called as the sum of 5 and 4. This 7 will be called the difference of 8 and 1. This 30 will be called as the product of 6 and 5. This 5 will be called as the quotient of 10 and 2. So here you can see that we are having different names to the different operations. Sum will be known as addition, difference will be known as subtraction, product will be known as multiplication, quotient will be known as the division. What will happen if I will say that 5, after adding 5 with a certain number, I will get 10. Or if you, for your easiness, let me take the 9 itself. This is a blank space. This is a blank space. Now we don't know its value. This blank space, this empty box, we don't know the value of this empty box or blank space now. So what we have to do that, these types of blank spaces, even though if I am saying about 8, minus with a box will be 7. 6 multiplied by a number will give you 30. 10 divided by a number will give you 5. So here you can see that we are having a different boxes, a blank boxes or an empty space. Empty space or blank box. So every time calling them as a blank box or an empty space will not suit us, or it will take a lot of time if we are writing blank space, empty box or something like that. So what we will do is that we will denote these empty spaces with any alphabet, with any English alphabet from A to Z, or usually we are using in small letters from A to Z. Any numbers we can, any alphabet we can write here. For example, I can write that 5 plus any number will give you 9. 8 minus any number will give you 7. 6 multiplied by any number will give you 30. 10 divided by any number will give you 5. So here you can see that you are getting an expression in which two types of terms are there. I share the word terms. Terms means two different numbers with a mathematical operation between them. So here you can see we are having two terms, 5 and a. Here we are also having two terms, 10 and x. Two terms also here, 8 and b. So terms means the different digits or different numbers with the mathematical operation between them. So I told that here we are having an expression with two different terms. Out of them, first value is always remain the same. That will be called as the constant. This value will never change. Can you change the value of 8 anytime? Can you change the value of 5 anytime? Can you change the value of 6 anytime, or can you change the value of 10 anytime? No. So these numbers are actually called as the constant terms of the expression. And this a whose value is not fixed, are called as variables. B here is the variable because the value of this variable is not fixed now. We don't know that. In case of this is the variable. So I hope you understood what are the constant and what are the variables in that. Now you can see that here when we are writing an expression like 2x plus 3, which is a combination of a constant, and a variable. So here you can see that whenever we are writing an expression with a combination of a constant and a variable, these expressions are actually called as algebraic expression. But when we put an equals to here, for example 2x plus 3 is equals to 10. If I am putting this complete will be known as now with the symbol of equals to as algebraic equation. I hope you understood now. If we have a symbol of equals to with us, that will be an algebraic equation. If it is not a symbol of equals to between the two numbers, it will only be the algebraic expression. Now, how many types of algebraic expressions we are having? If we are talking about the types of the algebraic expression, we have different types of algebraic expression. First one will be known as a monomial. Second one will be as binomial. Third one will be as trinomial. And fourth one will be known as polynomial. Now what do you mean by these names itself? The word mono itself says that one. So an algebraic expression which is only having one term. An algebraic expression which is having only one term, that will be called as monomial. For example, 4m, 9x, maybe 3 also, because 3 is also a constant which is also an algebraic expression without any other term. By word says that 2. So an algebraic expression which having two terms. For example, 2x plus 3, 7y minus 9, 8zx plus 2y. So these are the two binomials because they are having two terms with them. First term, second term. First term, second term. Now trinomial. I hope you understood now. Tri means 3. An expression which is having 3 terms. Example 4x plus 2y minus 3. So this is an example of trinomial. But what is the meaning of the word polynomial? Poly says that many. The meaning of the word poly is many. So an algebraic expression which is having, or I can say that more than 3. More than 3, like 9xy plus 3zx plus 4y plus 5z plus 6 will be called, which will be an example of monomial, which we call as a monomial. So I hope you understood all the different types of all the different types of algebraic expression: polynomials, trinomials, binomials, and monomials. Now we can see that I have written many type of examples here of different expressions. Can we see out? Can we give any particular name to the number which we are writing before an variable? For example, I have written that 7x square plus 3z plus 9 equals to 1. This is my one algebraic equation because it is having a symbol of equals to. So here, if we are defining how many terms we are having, so let us say that first term of this complete equation is 7x square. This is the first term. The second term will be as 3z. Third term will be, for your easiness, let us just simply write it as up to here. 7x square plus 3z plus 9. This will be my third term. First term, second term, third term. Now, we want to find out that this first term is made up of what? Means, what are the factors of this term? Factors. What are the factors of this term? 7x square. 7x square is made up of 7 into x into x. This 3z is made up of 3 and z. This 9 is actually not having any variable, so we will simply write it 9 itself. So these are the factors of this, and this complete diagram is actually called as the factor tree. This complete diagram is called as the factor tree. Okay, we have learned this factor tree, but my question remained still unanswered. I asked you, what should you call the numbers which you are writing before the variables? What should you call the number which you are writing before the variables? So see in this example now. Actually I made this vector tree to explain you, like we have x as the variable here and 7 as the constant here. So what should I call this 7 in respect to this x square? This will be called as the coefficient. This will be called as the coefficient of x square. This 3 will be called as the coefficient of z. Even see here, this 8 will be called as the coefficient of xy. So I hope you understood that these differs will be called as coefficient. Now I have to answer many different questions also, because many things are there which I already also don't know now. So one of the things which I don't know, that is now like and unlike expressions or unlike terms. Like and unlike terms. For example, 4x square, 3z, 9x square, 4x square y, 4z, 9x square y. Can we see that any terms which are having the same variables, like what is the variable here? X square. Any other variable, any other term which is having only x square? Yes, you are right, 9. So I can say that 4x square and 9x square are my like terms. Now look at the second one, 3z. Is there any other expression which is only having z as the variable? Yes, very good. 4. So this is my 4. I can say that 3z and 4z are also my like expressions or like terms. And what about this 4x square y and 9x square y? Are they the like? Yes, because here also x square, y and y. So I can say that they are will be called as the like terms. But if I am giving different question to you, like, can you tell to me whether 4x square y and 8 y square x are like or unlike? Whether they are like or unlike? Any options for you? Yes, very good. They are unlike. How can you say them unlike? If I will draw the factored tree of this one, I can say that the factors of this 4x square y is 4. X square means x into x and y. If I will draw the factor tree of this x term will be 8 y x. See, 2x are coming here and 2x are here. No, 1y is there, only 1y is there, but extra y there. So they are not same at all. They are not same at all. So they are unlike. They are called as unlike. One more thing I want to mention here, whenever we are drawing the factor tree, in that, if we are drawing this expression, if I am drawing only terms will be drawn with the bold lines like 4x and 9y. But if we are drawing the factors will be drawn with the dotted lines. Factor will be drawn with the dotted line. So this is one important point here. So I hope you understood the like and unlike terms also. Now, other thing is coming as the degree of the expression. The degree of the expression. Like if I am giving any example for like 4x square plus 3z plus 2p, this is my expression. 2p cube. This is my expression. I have to find out what is the degree of the expression. I have to find out the degree of this expression. How I can find out the degree of this expression? Degree means like highest power. Degree says that the highest power. So can we say that what is the highest power of this one now? 2, because it is only x square. What is the degree or what is the highest power of this term? Because here is no number is mentioned here, so we will always say it will be 1. If there is no number in the power, we will always consider it as 1. What is the power of this one? Highest power is 3 because it is p cube. So we can say that we have to take the highest power now. What is the highest power out is 1, 2, 3? 3. So degree of this expression will be equals to 3. Take one more example. 11 p square cube plus 12 xy plus 20 z square y square. I hope it is you can read that also. Now let us find out the power of this one. What is the power of p here? Power of p is 2 because two variables are here, so plus. What is the power of q here? If there is no number written means we have to take it as 1. So total will be 3. What about this one? What is the power of x? 1. What is the power of y? No number means always we have to take 1. So total will be 2. What about this term? What is the power of z? Is z 2. What is the power of y? 2. So total will be 4. Now which is the highest number? Which is the highest power here? Yes, very good, 4. So degree of this expression will be 4. I hope you understood this one, and this is all about today's class. Please do many questions regarding these learned concepts, so that it will help you a lot and it will reinforce your language. Thank you so much. Have a nice day. See you in the next video. Bye bye.